Hi, welcome to Cloud on Air, live from Seattle. We host webinars every Tuesday. My name is Morgan McLean. I'm the product manager for our Stackdriver APM products, and today I'm going to tell you how to make your apps fast and reliable with Stackdriver APM. You can ask questions anytime, and we'll do a Q&A session at the end. So as I mentioned, we're talking about Stackdriver APM today. It's the tools that we offer that allow the next wave of service developers to manage their apps as reliably and performantly as we do at Google. Stackdriver APM is composed of three products: Stackdriver Profiler, Stackdriver Debugger, and Stackdriver Trace. I'll go and do an overview of these products in a few minutes, and then we'll do a live demo. As I mentioned before, these are the tools that unlock the same methodologies that we've honed at Google for years to our customers and to the broader market. As you may know, Google's been an extremely large microservices operator for almost a decade now. And we've developed a lot of our own methodologies, tools, and techniques that we now want to share with our cloud customers to make them more successful. Stackdriver APM can be used on apps anywhere, not just those running on GCP. So you've probably heard of the Stackdriver brand before. It's been around for some time, particularly with our monitoring product. Stackdriver is the suite of tools that we offer to customers to improve their development experience on the Google Cloud Platform. Stackdriver monitoring is what's most well known generally. It was acquired a few years ago from a startup, and it's been brought into Google, and it has stats and dashboards and alerts. We also have Stackdriver logging and error reporting, which does logs ingestion and analysis for our customers, and can also highlight logs that appear to be errors and alert you on those. What I'm talking about is Stackdriver APM. So this is our suite of developer-focused tools. It includes distributed tracing, production debugging, and continuous profiling, all of which we use at Google every day. So over the past few years, Google's been on a bit of a journey as a part of its cloud platform initiative. We've made a lot of headway and made a lot of waves by providing parts of Google infrastructure to our customers. Google had to invent a number of new methodologies, whether this was high-scale container orchestration or new storage technologies, in order to operate at extreme scale. And we've exposed these to customers. Some of these are through open source projects like Kubernetes and Istio, where we've exposed our internal platform Borg as Kubernetes and Stubby as Istio. But others are exposing services through the cloud platform. Examples of this include Spanner, GKE, and BigQuery, and there's many, many others. The next sort of pillar of what we've been providing is allowing customers to emulate our practices. So the most visible example of this is the Site Reliability Engineering Bible, which we published a few years ago, and there's a second revision in the works right now. I think it's being published pretty soon. And this allows customers to use the same SRE practices and methodologies that we've used across our SRE and dev teams at Google to keep ourselves at scale. Finally, Stackdriver represents the tools that we offer to customers. And so this is the third pillar that would allow companies to emulate a lot of the infrastructure practices and tools that we have at Google to operate incredibly successfully. So for the past 10, 20 years, developers have been on a journey. If you think back 10 or 15 years ago, as a developer, if you started at a new company, it wouldn't be entirely uncommon, particularly at smaller shops, if they didn't have some form of source control or bug tracking or code review. And if you go back a slightly less amount of time, maybe 5 or 10 years ago for a services company, again, it wouldn't be entirely uncommon if they didn't have some form of distributed logging or metrics or alerts. It's just those tools were new, they were sometimes expensive, and not everywhere had adopted them yet. But today, as a developer, if you went to a firm of almost any size and they didn't have those, your instinct would probably be to walk right out the door, even if it was on your first day, because everybody in the industry understands that things like source control, bug tracking, metrics, alerting is incredibly important. And it's difficult, if not impossible, to become a successful company without these tools and these methodologies. We believe that distributed tracing, production profiling, and production debugging are on the cusp of being this next wave. Right? With microservices in particular, it's distributed tracing is such a powerful concept, and so are the others, that in a few years, our hypothesis is that it will be very, very difficult to operate without those. And indeed, if you look at companies like Google or others who operate at similarly high scale and reliability, you'll see that tools like tracing in particular are very, very common. And so it's our belief that this is going to trickle down to all companies of all sizes. So let's dig into the APM suite. The first component is Stackdriver Trace. This is probably one that at least some of the viewers will be more familiar with. Distributed tracing over the last year or so has been making a lot of inroads. Stackdriver Trace is a classic distributed tracing solution. And what that means is that it allows you to view real customer requests as they come into your services, and you can view them as they propagate across different services. So if a request comes into your front end, service A, and propagates to services B, C, D, and E, and so on, a distributed trace captures that. It's incredibly useful for understanding service topology, so understanding how those services call each other. And indeed, in an incredibly complex microservices deployment, sometimes it might be the only way that you know that. Secondly, traces are incredibly powerful for latency analysis. So we use distributed tracing at Google almost every day to understand how we can make Google.com and our other services faster and more reliable. The power of a distributed trace is that not only does it show you the hops that a request takes, but it also shows you how long it takes at each hop, and also which points were parallelized versus where you had a bottleneck. And so it's very, very powerful when you want to reduce the latency of a service, particularly tail latency. Google has made a lot of investments in this space over the years, and so you may have heard of something called Dapr. Dapr was a distributed tracing solution that we created at Google a long time ago. We published a white paper on it, I believe, in 2010. And in fact, if you look at many other distributed tracing solutions that are available on the market, many of them will reference that white paper as being what sort of gave them the idea for building this. And we're exposing Dapr to our customers through Stackdriver Trace. The next is Stackdriver Profiler. This is actually the newest entrant to our APM suite. Stackdriver Profiler is a continuous statistical profiler. So it's meant to be run in production, much like our other tools, continually. It's not a profiler that you turn on at certain points, and it's not a profiler that hinders your performance at all. Continuous profiling is very powerful. It allows you to understand the call patterns of your app in production, like the actual function call patterns within your code, as opposed to a trace, which shows you generally service call patterns. And it's very powerful for understanding how much CPU and memory every function uses. If anyone watching is a microservices developer, which I imagine many of you are, you might understand that profiling, much like debugging, which we're going to talk about in a minute, is generally something that you do for client app development. It's very powerful, it's very useful, but when you've moved to web services, particularly microservices, it's very difficult. With Stackdriver Profiler, we give you this data and allow you to discover where time is being spent, where memory is being spent, and so it's very powerful for general performance improvements, as well as reducing your costs. And we use the same technology behind this at Google every day across almost all of our biggest services. Finally, we have Stackdriver Debugger, which in some ways is probably the most magical of these three tools. Stackdriver Debugger is a production debugger that's safe for use in production environments with real customer traffic going through them. Rather than creating traditional breakpoints, it creates what we call snapshots, which are effectively breakpoints, except they don't halt execution. So you can lay them down in our very simple IDE-like interface that shows your code. When they get triggered with real customer traffic, or if you trigger them yourselves by mocking a request, they capture the local variables and the call stack, but they don't halt execution, which makes them really, really powerful for root cause analysis. Debugger also has another feature called log points, which allows you to add log statements to your application across all of its instances in real time, so you don't have to redeploy it. So again, really powerful root cause analysis tools. And let's just double click on these for a second. So all of these services offer lightweight open source instrumentation. So for tracing and for app level metrics, our instrumentation is done through a project that we run called OpenCensus that we're collaborating on with a number of other vendors. And OpenCensus provides libraries that you link to your app that'll capture traces, app level metrics, and you can also add your own information to get sent back to us. Our remaining products, so Profiler and Debugger, also have open source instrumentation. It's not part of OpenCensus, but they're all open source on GitHub. And we think this is really powerful for developers because they can understand how we're actually interacting with their app. If for some reason they need to make a change to the instrumentation, they can do so and rebuild it. And it's really easy to use because it's tied into your source control system. So you're not deploying agents to a VM or updating them there. You're simply typically adding a library, linking a library to your application, or for Java, you're referencing it as a Java agent. You can check in, rebuild your app, check in that change, and deploy it. And you can roll forward and back between versions through source control. So it's really, really powerful and really easy to use for developers. We support a number of languages. So on Trace and Debugger, we support Java, Go, Node.js, .NET, Ruby, Python, and PHP. On Trace, we also support C++ instrumentation. Profiler is quite new, so the amount of instrumentation is lower. Right now, we have support for Java, Go, and Node.js. and we're building right now, and hopefully it'll ship pretty soon, instrumentation for Python 3. Profiler is free during the beta test period. Debugger is currently free. And Trace is free up to 2.5 million spans per month, which is quite a bit. We expect most customers to stay within the free tier. And so now I'm actually going to hop to a live demo. So what I've done is I've taken a microservices application, actually developed by Weaveworks, called SockShop. And it's available on GitHub. And it's a really useful application for testing out both monitoring systems and microservices deployments. And we've taken this code and we've deployed it to a GK instance. And so you can see all of the services here. And SockShop's a really great demo for our products, both because it has, I think, roughly 8 different services written in different languages. So it's got 3 Java services, 3 Go services, and I think 2 Node.js services. But it's also useful because it wasn't written by us. There's always when you're a vendor, there's always an incentive to build a demo that works with your technologies and can show off your golden path. SockShop's really powerful because it emulates a journey that many of our customers would go on when they're taking their application, whether it's running on-prem or in GCP, and trying to instrument it and use Stackdriver. And so it was a great learning experience for the team, but also a great demonstration for our customers, for demos like this, to see how our tools interact with a code base that might resemble their own. So let's dive into Stackdriver Trace. This is the main UI for Stackdriver Trace. We present captured requests, or traces, on a scatterplot style view. This is useful for 2 reasons. First off, you can get a general understanding of the latency profile of your application from the scatterplot. But secondly, it makes it really easy to acquire traces. Today, our sampling for traces, so we don't trace every request, we trace a certain percentage of them. Our sampling is somewhat random. And so generally, as a developer, you're going to be interested in traces that have some kind of unique characteristic, whether that's ones that have high latency, which is what I'm clicking on in this case, or traces that are correlated with an error or some other interesting event. And a scatterplot makes it really easy to acquire, in particular, the high latency traces. And so I'd run a load test against SockShop and generated a very high latency burst of traffic. In fact, the latency at some point was up to 40 milliseconds. And we can use this UI to quickly acquire some traces. Now, most of these are requests to the cart service, which are fairly simple. Request goes in, something gets added to the cart, response goes back. But what we'll do is we'll actually jump to a request made to the orders endpoint, which generates a really powerful trace because it crosses a number of services and has some custom annotations. And as you can see here, we have a much more verbose, much more powerful distributed trace. And so we can click through this and see metadata from each component. These components are called spans. You can understand which spans call each other versus which are parallel with the parent-child relationships that we show here. Really importantly, you can see where this trace became actually distributed rather than just being a simple trace. So you can see while this trace originated on the orders endpoint, it also hopped to addresses. It also then hopped to the cart service and eventually went to the shipping service. And so with a classic tracing system, you wouldn't be able to see any of this. But the distributed trace allows us to both understand the service topology and also where the latency was spent. And so you can imagine as a developer, if you were tasked with speeding up this service, you'd probably start looking around here at the cart service or further here down in the shipping service. Indeed, there's an async call here that doesn't appear to be actually running asynchronously. And so you might want to start with that for your latency analysis investigation. Next, I'm going to show Stackdriver Debugger. So as I mentioned, Stackdriver Debugger is very similar to a traditional debugging solution that you may have used previously, whether that's like a standard interactive debugger in IntelliJ or Visual Studio, except it's running in production. And it's running across all instances of your app. You don't have to attach it to a single instance. You just open debugger and just start working. And I'm going to show you some of the functionality. So we have a function here. This is the URL handler for adding a new item to the cart. We're in the front-end service, which is written in Node.js. And what I'm going to do is just a simple example. I'm going to lay down a new snapshot on this line, and we're going to look for the value of customer ID. So if we go back to Weaveworks, and we add an item to our, or sorry, not to Weaveworks, SockShop, and add an item to our cart, you can see it there. And we jump to our cart, and we can jump to debug, and we can see that we've now captured this snapshot. Now, in a real production app with real traffic, a snapshot without many conditions would get triggered almost instantly. That's because you'd be capturing data from real customer requests. And if you have concerns about PII, we have ways of hiding that from your developers as well. And so in this example, we can see that we've captured my customer ID here. And if I wasn't signed in to the sock shop demo, you'd see a null customer ID. Another cool thing that we can do is copy this. We can actually set it as a condition. And we can reapply the snapshot, or apply another one on the line above. And we can rerun the request. And while this doesn't necessarily generate an interesting example, because of course we know my customer ID, it really shows off how we have similar tools. You can see we captured similar tools to to traditional debuggers. So we can use custom conditions, and indeed we can use expressions to show the values of certain specific variables that you want to capture. And we also show the call stack here. So it's a really powerful debugging tool. You can imagine for root cause analysis, you can use this to find out both the state of your system and if certain control flow systems aren't working as you expect. The next feature that I want to show is log points. So log points allows you to add log statements to your application instantly. And you can add conditions or use your own log, add a custom statement. So what we'll put here is we're going to print out the customer ID. So first we're going to say OnAir webinar, and we'll print out the customer ID. We'll apply this. And one of the really nice things about log points is that it works on it works with different logging systems. So in this case, we're using Stackdriver logging, which, as I mentioned before, is our in-house logging solution that we offer to GCP customers. But if you were using another logging solution or just capturing logs locally, Stackdriver debugger log points would work fine. It's really, really nice. So we'll add this to the cart, and that will capture a log statement. And this can take, this isn't as immediate as a snapshot, but if we start searching through our logs here, we're going to say log point. And you can see we captured our log statement right here, and we can view it inside of the debugger UI. So you don't even have to jump between debugger and logging when you're performing these kinds of investigations. It's really, really nice. Finally, we're jumping to Stackdriver Profiler. Now, I admit this is a different GCP project. We have one that generates really nice profiles and is great for demos, so I've switched to that. And the code in this app that we're profiling is it's an application that constantly zips and unzips a file. So it's basically just compressing and decompressing data continually. And so it generates a really nice flame graph, as opposed to a demo app that gets very little service. What you can see here is the flame graph that we generate from capturing those profiles. On the vertical axis, you can see the different names of functions, and you can see their hierarchy. So in this case, busy work calls busy work once, which calls writer.write, and so on. And on the horizontal axis, you can see the amount of the resource being consumed. In this case, we're looking at CPU time. But Profiler also supports heap profiling on languages other than Java. We're working on Java. There's some restrictions in the JVM, as well as thread and contention profiling. And as I mentioned before, this is a continuous statistical profiler. So we have effectively no performance impact on your application. It runs always in the background, so you can capture real data. But the way we do this is by having the profiler agent generally run on a maximum of one instance at a time and only take samples every so often. So we'll capture profiling data for an hour or a day or a week or longer, and then we'll take the aggregation of that and build this flame graph. So it gives you a really good view into general system performance. So you can see in this example in the flame graph, if you were a developer who had been tasked with either improving the performance of this application or reducing its cost, you'd probably be interested in this compressor.deflate function. And that's because it takes up a lot of horizontal area, just like the ones above it, but its children don't. And so it has a very high, what we call self-time. In this case, it's consuming 53% of the CPU is being consumed by this function and not by its children. And as a developer, you'd be very, very interested in that. Now, if you know about compression, you'd probably know that the deflate process will take a while. That might be expected. But we've had customers who have had examples where this was a function they didn't expect it to be, like a regular expression or something else, where a significant percentage, not 50 or anything like that, was consumed by code that should not have been consuming that much CPU. And as a developer, you can very quickly see that from the flame graph. We had a number of customers in the alpha report that with about 1 hour, roughly 1 hour of work with Profiler, they saved about 10% off their bill, which is incredibly powerful. And if you can imagine operating at extremely high scale, like some of these groups, it's a lot of money. If you were tasked with doing a micro-optimization or improving a small part of the system's performance, you can also just click on your area, we'll zoom in, and you can then get a better view of where your CPU time or memory or other data is being spent. So really, really powerful. Profiler is quite new. We have some new features that will be coming out fairly shortly, including what we're calling, we don't really have a name for it yet, but what we're calling sort of weighted profiling, where we're going to give a higher weight to profiles that are captured at periods of high CPU or resource consumption, so you can get a better view of how your system is performing in the worst case as opposed to the average case. And so that makes it more powerful as a tail latency, a solution to attack tail latency. We also have some integrations that are pending with Stackdriver Trace. So let's hop back to our presentation. So to recap over what we just went through, because I know it was quite a bit, we have Stackdriver Debugger. Debugger snapshots and dynamic log statements remove a lot of steps from your root cause analysis cycles. So you can imagine that snapshots or laying down log points would replace your traditional debugging steps that you might have today. At a lot of companies, when there's a code error, what they have to do is, when they don't know where it is, they add log statements to their code. They then redeploy their app with the error still in tow because they don't know where it is and they don't know how to fix it. Once the app is redeployed, they look at the telemetry from those log statements. Hopefully it tells them where the code error was or what the problem was, but it might not always, and you have to redo that steps again and again, and if you have a slow deployment cycle, that takes a long time. And so debugger reduces this to almost zero, right? You can use snapshots to find those issues, to find out if certain if statements or loops are being triggered, if things are not operating the way you expect them to be, without having to redeploy your app, and you can do it across all of the instances of your app seamlessly. So no more attaching a debugger, no more testing in a non-production environment. So really, really powerful. We use this at Google all the time. It's a pretty magical feature that we wanted to expose to our customers. Next, we have Profiler, which operates at extreme scale and isn't limited to analyzing single transactions. One of the biggest uses that we've seen of customers is both cost reduction, but also finding slow memory leaks. And because it operates over a long time, and because you can change those time filters, by dragging your view through time, you can actually see if certain functions are now consuming more and more memory, which would imply that there's a leak there. We have a number of new features coming to Profiler throughout the rest of the year, and we're really excited to see where it goes. Finally, we have Stackdriver Trace. Distributed tracing for the last few years has become generally better understood by a lot of our customers, and indeed the industry at large. But tracing tools tend to be either expensive or difficult to adopt. There are some open source solutions in this space. Generally deploying your own can be quite challenging, and a lot of the paid solutions are quite costly. Stackdriver Trace isn't. It's easy to get started with. For most customers, it's effectively free, and it can give you deep insight into how your service topology works and also into how to reduce latency of your application. I want to touch on instrumentation one more time. So all of our instrumentation is Apache licensed and open source, and it's on GitHub. All of it, or we generally, not always in the case of debugger because it's not quite as useful, but we generally expose APIs that developers can use to capture your custom data. And what I mean by that is for tracing, you can create your own spans, you can add annotations to spans. So in the demo that I just did, some of those spans didn't necessarily represent RPCs or requests that went to other services. They were rather created by the developer to track what they thought were long-running processes. And for Profiler, we also similarly have APIs that you can use to capture custom data. For debugger on some languages, we have APIs that allow you to arbitrarily capture a snapshot. Our traces and app level metrics are captured via a project that we call OpenCensus that we're collaborating on with other vendors. OpenCensus effectively automatically captures traces, allows you to annotate them, captures app level metrics, and then we'll send them to the back end of your choice. Stackdriver is one of those backends, but we also support Prometheus, Sipkin, and a number of others. I mentioned that we had an alpha test to Stackdriver Profiler. And so one of the groups that joined the alpha test with us was Snapchat. And so they had a lot of success with Profiler. They were able to find areas in their code where they had been consuming more CPU than they expected, so it was performing more slowly or costing more money than they had desired. And they used Profiler to both highlight those, because they didn't know about them, and also to then optimize them. And so they were happy enough that they provided us with a nice quote that I'm able to share with you here. But Snap was certainly not the only participants in this alpha. I know at Google, GCP, we like to talk about Snapchat a lot in particular. We had a number of companies, and as I mentioned before, we heard from a number of customers that they, with roughly 1 hour of time, they were able to shave about 10% off of their bill. So let's sort of summarize what we've talked about. So Stackdriver APM is an essential toolkit for the next wave of developers. It unlocks the methodologies and the tools and techniques that we've used at Google over the past decade to operate at extreme scale and to ship code safely and quickly. And it provides these to customers around the world. These customers might be running on GCP, they might be running on-prem, they might not even use some of our services, and that's okay. We want them to use Stackdriver APM, and we're really excited and really proud of the functionality that it provides. Developers can use these tools generally on web services, but also on other things or slow-running processes. And it really is going to just provide a lot of insight and a lot of confidence, I think, to engineering organizations about their ability to understand what their service is doing and their ability to ship code rapidly. As I mentioned before, it works on services hosted anywhere, whether that's any other cloud or on premises. And we're pretty excited about it. All right, so that wraps up the presentation. We're going to hop to Q&A in a few minutes. Thank you very much. All right, we're back. So we gathered some questions from the audience, and I'm going to answer these. The first question is, can I debug Node.js or Angular code running on my local machine, like my laptop? How can different reports help the understanding of issues? So I'm going to guess that by debug you mean Stackdriver Debugger. And yes, you can use it to debug code that's running locally or anywhere else. We've used it both internally at Google and other places where, in fact, the instrumentation is running on someone's laptop. One of the other things that I forgot to mention during the demo is that you can also, to view the source code, you have to pull it in from another source, sort of syncing it from another source to pull it in. And so if your code is stored on GitHub, on Bitbucket, on GitHub Enterprise, on GitLab, or the Google Cloud repositories, you can just use your credentials to automatically make the code show up in Stackdriver Debugger. The other thing you can do for this laptop debugging scenario where you might not want to be storing the code elsewhere because you're just doing something simply locally, is you can, and if we can just cut to my screen, in the debugger, you can go to the Add Source Code UI, and you can actually select local files. And what this allows you to do is actually pull in source code that's stored locally from your machine. This is useful for that local debugging scenario that you're asking about, but this is also useful when you've made edits that are running elsewhere, not on your primary service, or when you know the exact version of code that's being deployed and you want to debug it. So you're not forced to pull it in through GitHub or other sources. Another interesting thing about this feature is that we actually don't save your code to Google. It simply syncs locally to your browser, never gets sent to us. And so if you have any security concerns or concerns about Google accessing your code, you don't need to worry. It's all pulled in just locally to your browser, never gets transmitted. The next question is about Profiler. The question is Python on the roadmap? If so, which quarter? Same question for Scala. So Python is actually already being worked on. Right now we're working on Python 3 support. We plan on supporting Python 3. We're debating Python 2 right now. If you have opinions about supporting Python 2, please let us know on the Cloud Insiders mailing list or through in-app feedback. But yes, Python's on the roadmap. My understanding is it's going to ship within the next 2 months. I don't quote me on that, but that's my understanding. And that will be Python support for VMs and containers. So that includes the Google Compute Engine, Google Kubernetes Engine, or VMs or containers running elsewhere. We're going to revisit the support for App Engine Standard coming up soon. We know that Python's incredibly popular there as well. Same question for Scala. I'm not certain about that. I'd say I have to get back to you, but I don't actually know how to reach you. But Scala, I don't know. I know that Debugger supports Scala. But I'm not certain if Profiler does or does not. It ties into the JVM via the agent interface, so I suspect it might just work, but I can't speak with confidence. I apologize. The next question, what's this open census thing that I keep hearing about? How's that related to this? How does open tracing relate? That's a very good question. So open census, as I mentioned during the presentation, is an instrumentation project for tracing and for app-level metrics and tags that we're participating on with a number of other vendors. Open Census actually ties back to a project at Google called Census. We probably could have gotten cleverer with the open source name, but whatever. And Census is it's a library that's automatically attached to every job running at Google, so every container running at Google that automatically captures traces and metrics and performs the appropriate correlations. Open Census is just our externalized version of this. We've been really successful internally. We want to bring those same benefits to the community. And part of the reason that we've been participating with other vendors is that tracing instrumentation can be very difficult. One of the challenges of distributed tracing is that you want to be able to automatically propagate context, so like a trace ID, for example, from incoming to outgoing requests and do that across services. This is somewhat easier inside of a company like Google, where we generally use the same libraries and same APIs. But in the external world, this is challenging because you need to support every language that your developers use. So we target 8 for Open Census, as well as every single web framework, RPC framework, storage library, and so on, so you can generate both interesting traces or at a minimum propagate context. This becomes very difficult. It's very expensive for vendors to do this, which is why we kicked off this effort with the community and with other vendors to work together on building these libraries. And to be clear, Open Census is a set of libraries. So each library contains the instrumentation, so those hooks into web frameworks, storage clients, et cetera. Contains APIs that you can use to manually interact with traces and metrics. And then it contains exporters, which will send these back to either Stackdriver or SignalFX or whatever backend that you're using. And so that's sort of leading into this next question about open tracing. That's sort of the big difference. Open tracing provides a generalized API for interacting with traces specifically. Open Census provides not just APIs, but instrumentation and an implementation that allow developers to operate on these. The APIs for open tracing and Open Census are slightly different. For tracing, obviously Open Census has many more APIs for metrics and stats and other things. They differ very slightly. We've had some meetings with the open tracing group about maybe alleviating that. But at a minimum, I think we've already taken a pull request that adds a sort of a supplemental open tracing API to OpenCensus if you have any open tracing instrumentation. So if you've already made investments in open tracing, that'll still work with OpenCensus. All right, next question. For Profiler, is there some smart profiler concepts that highlights likely problem areas, a la ML, for inspection for a developer or a trained production support engineer? That is another great question. So Profiler, as I mentioned, is quite new. While we've been using it for some time inside of Google, it's only just reached beta state, I think 2 months ago, for external customers through Stackdriver Profiler. And so we're adding a ton of features as we speak. So if I think about the concept of smart profiling, I talked about the weighted profiling during the demo, and so what this will do is allow you to more selectively your application when it's running into CPU or memory problems. And so you'll get a more effective flame graph out of that you can use to perform your own analysis. And that's really useful when you're investigating poor performance as opposed to just general like cost reduction. And so that's a sort of smart profiler concept, though it doesn't use ML, that we're adding to the product as we speak. If I think longer term, there's a lot of integrations we have planned between Stackdriver Profiler and Stackdriver Trace. In particular, this will make tail latency analysis really, really powerful. So trying to reduce the latency in the 95th percentile case or 99th percentile case. And when I think even longer term, that's when things like ML come into the picture. And it's certainly not just for Profiler, but in general, just using ML on all the signals that we collect, whether those be traces, metrics, profiles, and so on. And so we will be making investments in that, and we have some people already thinking about this. But Profiler is in an early enough state that we're mostly focused on just adding features that developers can use on their own rather than having the computer solve it for them to identify places of poor performance or identify areas where they can improve the speed of their application. We have some other similar really clever features coming to Stackdriver Trace. So as I mentioned during the presentation, we do random sampling for requests today. And so this is useful because it gives you a good profile of the latency of your app. But one of the challenges is that, of course, most of the requests that you capture might not be interesting. We're going to switch that pretty soon to do what we're calling deferred sampling. So we can sample based on accumulated latency or the presence of errors, which will also improve the sampling for Trace. Much like I mentioned, we're investing in smart profiling features. We're making these investments to make tracing much more powerful and effectively just a smarter distributed tracing system. And those features are being added to the OpenCensus project so that not just Stackdriver, but other vendors can benefit from them as well. Next question. I don't use Stackdriver today. How hard is it to get started with APM? How long does it take for my developers to go from 0 to ready to debug? That's a good question. So Stackdriver is really, really easy to get started with, particularly Stackdriver APM. So today, I can actually speak to this very directly as I instrumented the sock shop service that you saw during the demo. If you're starting from scratch, so you've never used any kind of APM or tracing or profiling system before, what you do is you get the OpenCensus libraries, you link those to your app, you get the one for the correct language. In most languages, that will mean that once you do that, you'll get traces and app-level metrics automatically. In some languages, particularly Java, you have to do a small amount of work just to plumb through the correlation. We have a lot of hooks that make it easy, but we can't do it fully automatically, particularly if you're crossing thread boundaries. So you do a bit of work to get trace correlation working. Even if you don't do that, you'll still get the metrics. Then you can link the profiler and debugger agents to your application. So in Java, that's a Java agent that you put in your Java launch path. In other languages, it's typically just a library you link to your code and redeploy. If you're running on GCP, for example, if you're running on GKE, as with this demo, that's all you need to do. You don't need to supply credentials or anything else. We pick those up automatically. And so with a few minutes of work, you can get most of these tools, or if not all of these tools, working perfectly. If you're running on premises, you'll need to supply your service account credentials, which I think you can do via environment variables or just via, if you can embed them directly in your code. You can do that, and then your APM instrumentation will start responding back to us. The second part of the question was how long it'll take developers to go from 0 to ready to debug. These tools are very intuitive. If you think of the UI that we have for Stackdriver Trace or Stackdriver Debugger, This, with debugger in particular, we try and emulate a classic IDE interface that you've used if you use really any text editor, but in particular IntelliJ or Visual Studio, which have built-in debugging. We try and emulate that. We found that for debugger, like engineers just get it almost instantly. It's exactly what they're used to. It works exactly as you would expect, and there's no need to even attach to particular instances. So we found that teams are able to get started with this really quickly. We're doing a lot of work later this year to better integrate these products, and so to provide like a single seamless UI where you can jump between like traces, errors, snapshots, and so on. That should make it even easier for people to get started. But in its current implementation, I think Stackdriver APM is pretty easy to get started with. All right, so that wraps up our list of questions. I think we're all done. So thank you very much for watching, and I'll see you soon. Goodbye.